Yeah? Okay, cool. So we're talking about microservices without servers. I need to get the microservices better. Oh, by the way, I'm Glynn, I'm from IBM. I'm a developer advocate. If somebody could post a picture of me on Twitter at some point during it would prove to my employers that I'm here and not entertaining myself around Amsterdam. So, something like this. But, so we're talking about microservices. We just need to get microservices out of the way first. So hopefully you know what microservices is. It's a means of, instead of building huge monolithic systems that have to be deployed where everything's in one piece, you can create smaller individual composable systems and deploy them separately. And say you're building something like Instagram, where you've got registration, posting to a social media platform, you've got image resizing, you've got notifications, all sorts of features. Each of those could be a microservice. And then if you're doing lots of image resizing, you could scale the image resizing service separately to the registration service, say. So I'm not going to go too far into what microservices is and its pros and cons, but the twist we're putting on it today is to do it without servers, in quotes. Because servers are killing your productivity. Now, at the end of this presentation, you will all rush for the door, and you will all be going home and setting fire to your servers. That's what I confidently predict. This is me back in 2005, a long time ago, with a stack of servers. Old servers. These were servers that I was decommissioning from an old system. And I was very proud of myself, as you can see from my big smiley face. I was very happy to be getting rid of these old, troublesome servers because they caused me a lot of pain. I was a lead developer at this point with a team of developers, and I was responsible for the uptime of this kit. And it was causing me problems. There was failures, hard disk failures, network failures, software failures, all of which was my responsibility. And I'm really a developer. I'm not a system administrator. But it was my responsibility to get it right. And let's just take a minute to chase the path of this application over time, if you bear with me. So I'm removing some old kit, but I'm replacing it with more kit. So I'm just buying some more servers and putting them back in to replace those ones, because that's the way it was done. So this is me, 2005, in the server room, which was in the same building as my office. It was just another room, right? This is sort of unthinkable these days for most companies. And when a server would last for 3 years, and then it would fall out of warranty. So then you would have to go back to the financial people and say, look, we've got this server's out of warranty. It's old. Can we replace it? And they say, yeah, how much is it going to cost? It's going to cost $50,000. Can you give me $50,000? And then that'll last you for another 3 years, maybe. And then we'll come back and we'll talk again. By 2008, I'd bought some more servers. These were the ones I'd replaced that pile with, were now obsolete. So I was buying some more servers. But in this case, I wasn't putting them in my own data center, in my own server room. We'd moved into a data center. And the data center people are very kind. They provide power from multiple sources. They provide heat removal services, which is great. They provide network connectivity from multiple sources, which I couldn't do from my server room. So all sorts of good stuff I get from a data center. A few years later, I was no longer buying servers. I wasn't even buying any servers from poor old Dell. I don't know what they did. But I was renting servers from the data center itself. I was saying, look, I'm going to need 15 servers, please, and I'll pay you per month. And that meant that I didn't have to go to the finance person and say, can I have 50,000? I could say it's going to cost you however much per month. And if I needed to scale it, it's much easier. In the old days, I would have to go back to the finance person and say, can I order a server? And then 6 weeks later, it would be replaced, and so on. You get the benefit. And this should be a familiar path to anyone working in IT in the last 10, 15 years. If we take it one step further, I no longer even rent physical servers. I rent servers, but they're not actually one-to-one with physical equipment. I'm renting virtual servers, which is a subset of a physical server. So things have got, let's just trace what's happening here. There's no capital expenditure. The monthly costs are getting smaller. the unit of scalability is getting smaller. So I don't have to buy a physical server. I don't have to buy a physical server. I don't have to rent a physical server. I just have to rent a virtual server. It's getting smaller and smaller and smaller. And let's look at my responsibilities in that time. I'm responsible for 100% uptime. This is the real pain, especially if you're a small outfit. So I was at one person with perhaps 3 or 4 people. This application had to run 24 hours a day. I haven't got 24/7 operations. I haven't got a control center where we've got people on shifts to make sure this stuff works. Yet I still have to do 100% uptime. And it's these little blips. It may work for a whole 6 months, and then a little blip. And that costs money. It costs the company traffic. It costs the company actual hard cash because they were a sales organization. And time off meant no sales. Bad. Scale. This is the other thing that kept me awake at night. So this is what happens if the company does a deal with another company and brings in twice as much traffic. Can my system scale? Not just in terms of, can I add twice as much hardware to it? Will it work? Will the database underneath it still work? And the company continuously did deals and made the traffic bigger and bigger and bigger. And this was a thing that worried me. And sometimes traffic is seasonal. Sometimes you get a lot of traffic at weekdays. In our particular use case, we got lots of traffic in the weekday, nothing very much at the weekend. We got a lot of traffic in holiday season, not so much else at other times. So very seasonal traffic, so we had to scale flexibly. This is a familiar problem for many web-based applications. And from my personal point of view, I wanted to do less ops and more development. I was a developer. I liked solving computing problems. I wanted to build better websites, better apps, better APIs. I didn't really want to deal with operating system patching, load balancing, networking, hard disks, solid state disks, whatever. Not really my core interest. I just want to write code. So although the cloud has brought me benefits, it's made it cheaper for me to build stuff and scale it. All of those things, if you go back to that chart over time, all of these servers, whether they're physical in somebody else's data center, whether they're rented or owned by me, or whether they're virtual, they are still servers. They're still a full stack server, all the way from the networking layer to the operating system to the stack of code that you need to have, let's say the Node.js or the Java virtual machine or whatever, plus your code on the top of it. And all of this needs to be maintained, plus all of the networking, plus all of the queuing, plus all of the traffic management is all of your responsibility. Whether it's virtual or physical or whatever, it's still a full stack. And the cloud didn't fix that side of it. The unit of scalability got smaller. It became easier to spin things up and dispose of things. But it didn't really solve it for me. It just transferred it into a different level of abstraction. What would have been convenient for me was to have computing to be more like a utility. So if I switch a light on in my house, I don't have to really worry about cabling, substations, transformers, turbines, fuel, and so on. I just turn the light on. And if I want twice as much light, I turn 2 lights on. And if I want it to be dark, I switch it off. And the bill I pay is directly proportional to the amount of electricity I use. Why can't computing be like that? Why can't it be 0 if I use 0 computing and go up in tiny increments, like a dimmer switch, just paying for more. The more light you get, the more you pay. It turns out that although virtual machines make it more efficient for a data center to split up a physical machine, it's certainly not optimal. This is from a study from Google, I believe, and they looked at the utilization of virtual servers on a physical server, and they reckoned that they were running at around 20 to 40%. And you probably don't want them running at 100%, or running hot all the time with all the fans blaring, but 20 to 40 is a little bit poor. And that, of course, means that there's a lot of space in data centers being used up. There's a lot of heat being wasted, a lot of electricity being wasted, and also, of course, that bill is then passed on to you, the customer. So There's huge savings to be made if you can fill out that utilization better, and that saving should get passed on to you, the customer. So along came Amazon to rescue us. So this is a few years ago, and this is the launch of AWS Lambda. And this is a brand new product, and it wasn't actually the first of its type to the market. But what they're bringing to you is a means of, you give us the code that you want to run on an event, and we will run that as many times as the event arrives. So we will handle the queuing and the scale and the networking and the whole software stack. All you have to provide is the little bit of code at the top of the tree, which is the bit I write. I'm the developer. I want to write the code. So this is quite appealing. And they will provide the scaling, and it scales from 0 to however much scale you need. So this is quite an appealing thing. It runs code in response to events. It manages the resources. I don't have to think about anything. I don't have to think about an operating system ever again. I don't have to patch a security thing ever again. I just have my code, my function. Why is this different? It's called functions as a service, and it reduces the point of scalability down to the smallest piece of code that you can. So imagine you've got an API, and you've got various endpoints in your API. Maybe you have one function that deals with one particular API endpoint. That is one function. And you give that to your functions as a service provider, and you say, run that. Whenever this API call arrives, call that function. Whenever this API call arrives, call that function. You have perhaps one function for each one. Really, really simple. And then they deal with the scaling, the whole stack. Scaling from 0 to n, this is the important bit. If my application receives no traffic whatsoever, I don't pay for anything. I may have said, call this function whenever this event arrives. If the event doesn't arrive, I don't pay for anything. So if you're a small company and you're developing a mobile application, say, there's a reasonable chance that your mobile application isn't going to end up in the top 10 of the iPhone App Store, right? Well, there's a lot of applications out there that don't make it, but a lot of money is spent on it. And there's probably a lot of fixed infrastructure sitting there waiting for the events to arrive. There's databases sitting there waiting for the events to arrive. There's web servers and all sorts of middleware sitting there waiting, and nothing happens. If you build with this sort of functions as a service, if no traffic arrives, you don't pay any money. So you've just wasted your own time. It's completely pay-as-you-go. And it's slightly better than that too, because there's usually a pretty generous free tier. So not only are you paying from 0 to nothing, you don't pay anything until it goes above a million functions per month, something like that. So that's pretty generous too. You can certainly test in that free tier without incurring any expense. And I don't know if you were in the previous talk when they were talking about continuous integration. If you wanted to, say, spin up a parallel service to test your stuff with, that's virtually free, because you're just messing about in the free tier. So, somebody said, I'm saving 80% from my bills. It depends on what your load is. So this person presumably had lots of fixed servers sitting there doing not very much. It's relatively efficient if your servers are busy to have fixed servers to do it, right? But if your traffic is peaky, lots of traffic the weekend, not very much in the weekday, then you've got lots of servers sitting there doing nothing. So in this particular case, this person was able to save 80%, so hurrah. Is this just platform as a service? Has anyone heard of platform as a service as a thing? Just to level everyone off. A platform as a service is a bit like this, except it's a slightly app-based level. So say I create a Node.js-based web server. I provide the full Node.js source code with all the libraries and say, look, this is an Express app, and it's going to listen on port 80 or something. And then I say to my platform as a service, run 15 of these. And it deals with the Node.js layer, and it deals with the operating system layer and all the networking and that sort of stuff. But I'm still writing an application that has to be running 24/7. So it's just like a web server, say, in this particular instance. And that's fine, platform as a service, but the unit of scalability is a full app. right? So if I can have one of them, or I could have 3 of them, or I could have 15 of them, I have to scale per instance. Whereas functions as a service, you're really saying, I don't know when these events are going to arrive, and it doesn't really matter. You sort it out. Whether it's 0 or 1 million of them, you work it out. And that's quite cool. So if you were doing it on platform as a service, you might say, look, I can't just have 1 server running because it might fail. So I'm probably going to have at least 3. And your initial cost is going to be, say, 3 servers with the load balancer. So functions as a service can help you there because there are lower fixed costs. So Lambda started the trend. This is Google, what do you call it? Trends. So, and yep, it's going up. It's increasing with popularity. And then if you trace alongside that the word serverless, it didn't really appear before then. Serverless is the sort of buzzword that is easier to say than functions as a service, right? So serverless was caught on perhaps a little bit later than that, but that's starting to pick up as well. And it's because Lambda doesn't have 100% market share in this. There's more than one serverless platform. There are lots of them, in fact. So there are offerings for the major cloud providers provide a functions service or a serverless platform. There's one from IBM, there's one from Microsoft, one from Google, Amazon's, of course. So they're aligned to their particular cloud platform. So if you're dealing with an Amazon-based system, then it might make sense to use the Amazon serverless platform, similarly with all of the other clouds. But then you've got these other serverless providers which are aligned to event-driven things. So Twilio is a telephony provider. They deal with text messages and telephone calls, very event-driven stuff. So they've got their own serverless platform. So you can say, look, whenever a text message arrives, call this function and decide what to do with it. There's a company called Iron.io. It's not very clear on there. They deal with queues. So they have a queue. And then you can say, look, when something arrives on the queue, run this serverless function against the queue, and I'll just throw data into the queue. You work it out. So these platforms are either aligned to a particular cloud, because you want all your stuff to be in one provider, or they're aligned to other products or other event-driven things. And I suspect if we looked in a couple of years' time, this might be a bigger set of providers here, because it's a really convenient way to program. If you're interested in serverless specifically, there are conferences. This isn't just the only one. There are several conferences, one this month actually in London. They sell out really quickly. It's kind of a real buzzword thing. And you might want to be on the bandwagon sooner rather than later. But it kind of depends on what application you've got. If you want to do your monthly payroll, for instance, you probably don't want a serverless system doing it, for reasons we'll come to. And this is where I burst the bubble for you here, people, because I'm sorry to tell you that when I say serverless, there are still servers somewhere in some data center somewhere. What it really means is there are it's not a server that you can SSH into, that you can patch, that you can change the configuration of. Someone else is managing this infrastructure for you, so you don't have to. Of course, there are still servers, but you literally don't have to understand how it works to be able to run it. You can just say, here's my function, you run it. I don't even know how it works. It's off in some cloud somewhere. With all of the other things higher than platform as a service, you need to know about the operating system. You need to know something about the cloud infrastructure and the security policies and how the load balancing works and so on. You're not really with this. We're not with serverless. So that's the background. Let's have a look at the code, because I don't want to take you through line by line. There's not actually that many lines. That's the point. I just want to give you a feel for what serverless code looks like. To do it, I'm going to talk about in the context of IBM OpenWhisk. OpenWhisk is one of those cloud-based serverless platforms, and it's the only one that's open source. So with others, you're locking yourself into one provider. In this one, you're not, because there are many vendors offering OpenWhisk as a service platforms, or you can run it yourself. It's part of the Apache Foundation. It's now called Apache OpenWhisk, which is great. It's an Apache incubator project. So the code is literally there, ready to be contributed to, which is great. It's not totally magic that you, you couldn't work out how it worked if you wanted to. It's actually described quite well in the README there. It tells you that about the technology stack and what's going on. Hint, there's some Docker involved. It's open source. There's the code. Can you see it? It's beautiful. And if you want to install it yourself, this is it. You actually just clone the repository, change directory. I know it's terrible. You have to change directory. And then you type Vagrant up, and a virtual server will appear, which will run OpenWhisk on your machine. So it's really, really simple to get started. You probably don't want to put that into production, but it's a great way for developing on a plane, for instance, where you're going, okay, where's my serverless, where's my cloud now, you know? So here's an action. This is OpenWhisk, the web. So it has a web-based UI. So if you don't want to do the command line thing, I'm a command line person. I like doing command line things because I can reproduce my actions programmatically. So I can say, look, I want this action, this action, this action. I want to deploy them with this script, and if it works, then do something else. If you want to, while you're getting started, though, it's quite nice to have some syntax checking and follow some guidelines and see what's going on. So there's a web-based UI. You just say, create a new action. You drop your code in, press deploy, and there you go. It's pretty straightforward. And then you can attach it to events to feed that code with incoming events. That's the idea. And you can use a mix of the web-based UI or the command line. It's up to you. So I'm generally coding in Node.js these days. But if that's not your thing, then you can write these actions in Java or Swift or Python. And if any of those aren't your thing, because there's a load of programming languages out there, then you can build your action, your function, if you like, into a Docker container and just hand over the ID of the Docker container and say, hey, whenever an event arrives, here's the Docker container you need to run. You scale it from there. So you can compile it down in C or whatever. Pick your programming language. And that's pretty cool. So what does the code look like? That's what you're... so I'm going to create... This isn't the code. So we're going to create a single OpenWhisk action. An action is the OpenWhisk terminology for a function that is run on demand when an event arrives. So basically, it's a function. It's called functions as a service, so it shouldn't be a surprise to you that there's a function involved. It's called main, and it gets some parameters. The parameters are usually the runtime things that change. They could contain your private configuration, how your database credentials, for instance, some environment variables, that sort of thing, which are common to each action, plus the runtime stuff that varies. Here's the event. This is what the person posted. This is the comment they made on Instagram. This is the registration. This is the password that they want of something. And whatever I return from my function is what gets passed back. It's not really very hard at all. It really couldn't be simpler. If it's synchronous stuff, and this is JavaScript, so it can get a bit fruity, you just do some logic and return some data. If it's asynchronous, you can return a promise, and it'll return later. If you like Java, and people do, then you can do it in Java too. And it's the same thing, but it's wrapped in some Java stuff. There's a main function, you get some arguments, and you return, in this case, a JSON object, which is the reply back. So if this is an API call, for instance, the parameters come in as args, and the JSON you return with is response. It's really very simple. Because you're not having to deal with creating a web server and all of the network infrastructure, you don't have a lot of scaffolding. So your code gets ripped apart, and you get right down to the logic that happens when the event arrives. So all of this scaffolding stuff gets put out the way, and you end up with just the logic. So how do you build these things up? Well, we've got events coming in. Let's say we're building a RESTful API, post / something, or get or something / something. So you define what your endpoints are for your endpoint for your API, and you can say, look, this API call, it will call this Node.js action, and whatever it replies will be the response. If you want to do something a bit more complicated, what you can do, you can make the function more complicated. That's fine. Or you can get a sequence of actions to run. So you can say, look, run the first action. That might do a bit of checking, and then pass the results from that into the second one, which might write something to a database, say, and then the third one might send an email or something. So that you can get a sequence of actions going where the output of one is the input of another. And that way you can reuse actions. Say your send email action could get used in various workflows when you don't have to duplicate the code. Or you can share the load between different programming teams. So it doesn't have to be all 3 Node.js ones. It could be a Node.js one going into a Java one, going into a Python one, if you really want to make things interesting. But the actions are independent of each other, is the point. So what can trigger change? It's an event-driven platform. So the change could be somebody commits something to GitHub, or comments on a post on GitHub, or merges something to master. It could be the changes feed from a database. So Cloudant is supported out of the box. That's a NoSQL database. So whenever somebody modifies a record or document in Cloudant, call this action. Do something with it. The top right logo is Apache Kafka, which is means a big streaming holding bay for moving data. So you can say, look, whenever some data arrives on this Apache Kafka topic, run this OpenWhisk action, however much traffic arrives. Then we've got push notifications, and we've got time. Time is a great one. So if you're writing a cron, for instance, you want to say, look, at 12 o'clock every day, I want to query the database and send an email to my supervisor with the stats for today. If you do it normally, you'd have to have a computer running 24/7, and then run a cron that says, at 12 o'clock, run this script. You can just say, look, run this serverless script at 12 o'clock, and you only pay for the execution of it. And you can have as many of these running as you like. Pretty cool. And of course, an action can create other actions. So you can say, look, that maybe this time-based one pulls something from a database and says, oh, 50 things have happened. All right, spin up 50 more actions that are each going to deal with each one individually. So you can scale out in a sort of fan out from there. So what are the good use cases for it? Well, I'll go through a couple of use cases, and then we'll talk about the downsides later. So chatbots are one of the use cases. So if you were to say, so this is a hotel. I didn't stay here last night. This is a pretend hotel. And it looks very nice. But they're a small outfit, and they don't have somebody there to answer the phone 24/7. So they have a website, of course. But what if someone's got a question? What if somebody wants to make a booking? What if somebody's got a query and they can't find the information? Well, they have a little chat thing in the bottom right-hand side. Sometimes they're powered by humans, which is fine. In this case, we're going to power it by a bot. So somebody clicks on the thing, and it sends a message to our server and says, hey, can you help me? I wonder if they can see that. OK. So I click hello, and I say hello. And the concierge says, hello, how can I help you? And it says, I'm looking to make a booking on Saturday, please. And the concierge says, well, what time on this date would you like to make a booking? You get the idea. So each of these, so this is a JavaScript on the client side. It's making a call to the service, some server-side script, and expecting a response, which it's rendering there. Not very hard to do. But I don't know how much traffic this thing's going to get. Do I want a server sitting there permanently? Do I need 3 servers to sit there permanently to deal with this traffic? Or obviously, I'm going to use OpenWhisk or a serverless platform. Otherwise, this wouldn't be the talk about serverless. So I've got a JavaScript widget. I'm using OpenWhisk really as a proxy between the JavaScript side and some other API service at the back end, whose credentials I can't put in the front end because they're private. So they're encapsulated in the functions as a service thing. And when he says hello, it gets passed to Watson. Watson works out what that means and sends the message back and so on. Really straightforward. Now, OpenWhisk isn't really doing very much there. It's performing the job of a proxy. But I could add to it. So I could say, what happened last night? How many questions did the service answer? Well, I don't know. I wasn't saving it. Well, you can save it. You can just add to your action, say, let's save it to a database. And then we can say, well, how many people are making bookings? How many people, what are the bookings? Otherwise, you've lost them. How many people are asking for, have you got a Facebook page? Oh, we need to make our Facebook link more prominent. And, you can start feeding back and and making your service better. So if you start with the serverless thing, you can still add to it. It doesn't have to be really tiny things. In the UK, we have an elected government of sorts, and we have, if you want to petition the government, they provide a website to do it. And if you can get 100,000 signatures on any particular issue, then they promise to debate it in Parliament, which is pretty cool. So one day someone will say, I want free ice cream for everyone, and it gets 2,000 signatures. And sometimes it gets really popular, like somebody says, stop Donald Trump from making a state visit. 1.8 million signatures, which arrived in about 2 days. So it's a very peaky traffic. So it's a classic web application that you don't know how much traffic it's going to get. How many servers do I need? And if I scale it, I have to scale by server or some sort of auto-scaling profile. Obviously, you're going to use serverless, right? So this is how it works. And I wanted to make this completely serverless. I wanted no servers that I looked after involved in this whatsoever. So I was building the equivalent of this. I'm not the person that built the UK government's petition system. This is just a demo. So first of all, how can I serve my web page? Well, GitHub Pages. Has anyone used GitHub Pages? Some people will have. So if you've got a GitHub repository and you switch to the GH Pages branch and put some HTML in there, then it will serve it out as a free web server. The CSS and the JavaScript and the HTML. So you can create a nice static website for nothing. You can point a domain name to it as well. So I could call it, ukpetitions.com, point it to that GitHub repository, and I've got free hosting, effectively, which is great. It's all controlled by source code controlled under Git and everything. So that's my serverless static web hosting. But of course, this is a form, and it collects some data. So I've got to deal with that. Well, that's handled by OpenWhisk. So whenever somebody submits the form, OpenWhisk has got 2 jobs. Write to a database, send the person an email so that they can't cheat. So you send an email with a complicated token in it and say, you click on the link, otherwise it's not counted. So how do we build that? Well, when they click on the link, another web page is rendered, another call is made to OpenWhisk, and we mark it as complete, basically. That's just going around the loop. And this is how it's built. It's 2 OpenWhisk actions paired to 2 API calls. When you submit the petition, it verifies you've made the right sort of things. You fill the forms in. It looks like an email address, that sort of stuff. Just some sanity check. And then we write the data to the database in the second action, so the output of one becomes the input of the other. So it writes to a database, and then we use a third-party emailing system. This is SendGrid, which is not affiliated to me in any way, but they have a sort of free trial, 10,000 emails in the first month, and then pay as you go. So effectively, I've got free web hosting, I've got free serverless computing, and I've got free database storage, so Cloudon's got a free tier as well. And I've got free email bulk sending. So I can run this for nothing, probably. And then similarly on the way back, if the signature is correct, then we mark the thing as complete, otherwise we don't. Hurrah, a completely serverless platform. In other words, I'm not going to get buzzed at 3 in the morning when it doesn't work. Somebody else will, which is the way I want it. So you can go back to your data center of choice and set fire to your servers because you don't need them anymore. You can switch all of your applications to serverless. Obviously, that's not really true, right? Not all applications are suitable for switching to serverless. The ones which are things which are inherently event-driven, things that receive the outputs of web forms, the things that respond to notifications, the things that are peaky in traffic, things where you're unsure whether you're going to get 0 or lots or something in between. So event-driven small applications. Oh, by the way, don't set fire to things. It's very dangerous, and you could hurt yourself. That's a legally binding warning. I'm not responsible for you setting fire to things. Sorry about that. So what are the limits here? If it's not suitable for big, long-running things, what are the limits? Well, it's designed for small, short-running jobs that would consume small amounts of memory. So typically, the default is something like a Node.js application with 256 meg of memory, which is tiny, right? It's like a Raspberry Pi. Where the execution is less than a minute, the Docker image would be killed after a minute if it's still running. So it's designed to just deal with, get an event, deal with it, perhaps store it in a database, and then die. It's not designed for something that's going to run and run for hours and hours. And you pay per gigabyte of memory you use, and for every 1/10 of a second of computing time you use, multiply that by the other, and then the billing comes in. And then there's a generous sort of free tier where you're saying, as long as you use less than 1 million requests at this level. So that's the computing limits. Another thing to bear in mind is that when you're offloading most of your stack to somebody else, you need to see what's going on, because it's still your responsibility to fault find things. So you want to be really good at monitoring. You want to be really good at debugging. You want to store everything wherever possible, because if something goes wrong, where has it gone wrong? The machine that it was running on is no longer there anymore. It's gone. So it just didn't exist. It stopped being. As soon as you returned, it gets switched off. But testing's an interesting one. Testing becomes really simple here. It's just like unit testing. You've got a function with an input and an output, and you can try all the inputs and you can try all the outputs. You can use traditional unit testing frameworks. You can deploy it to a parallel, serverless framework and to test it in real life too. If you want, you can unit test it on your machine, and you can test it in situ on a live OpenWhisk platform or equivalent. So there's no excuse for testing just because the code is small. In fact, it makes your job easier. It's just the whole system interaction. I would also say, before we get into frameworks, there's another thing that you might want to bear in mind here, which is if your application is connecting to a database, if it's a permanently running application, when it starts up, it connects to the database, and it keeps that connection going. And that connection is relatively expensive. It's got to, say, do a DNS lookup. It's got to make the connection. It's got to do authentication. And then it keeps that connection open. With these sort of serverless things, they don't. So that expense of connection per thing is done every time. So it's probably going to put extra load on whatever's at the back end. And that extra piece of time it's going to take to connect to the database or whatever is expensive to you, because you're paying for the compute. So just worth bearing in mind. If you're into frameworks, sometimes people don't like to write just the code. They want to write it in the framework of something else. And with good reason in this case, because the Amazon one is relatively complicated. There's a lot of scaffolding you have to go through before you deploy it to Lambda. And this serverless platform, this framework, hides a lot of that complication for you. So you just have your code, it wraps it in the scaffolding, and then it sends it to. But it also works with other, the Microsoft and the OpenWhisk one and others. So you can write your code once, and it will convert it into whatever form is needed for the other clouds' serverless platforms, which makes you a little less locked in. So that's pretty cool. If you want further details, there's an OpenWhisk Slack. There's openwhisk.org. It's the Apache project. That's me. There's an OpenWhisk Slack, and so on. The slides are on that URL at the top if you're interested. Otherwise, I would ask you for questions. Thank you very much.